Signal detection theory is commonly used to assess recognition memory performance. Under signal detection theory, it is assumed that discriminability and the placement of a decision criterion are independent processes. That is, a shift in decision criteria shouldn't affect discriminability, and changes in discriminability shouldn't affect the placement of a decision criteria. In this study, we assessed this assumption and compared performance against 3 other models that had less constraints to determine if the signal detection theory model is the best model, specifically at the individual level. We manipulated both discriminability and the decision criteria during a recognition memory test where participants had to rate their confidence as to how well they thought they remembered an old or new images. Participants initially viewed several face images either once or 3 times, creating 2 discriminability conditions. And the criteria manipulation was whether or not there was 70% of the images that were old or 30% of the images are old. This created 4 different testing conditions that every participant underwent. For each of the 4 testing conditions, participants provided 6-point confidence ratings, which allowed us to capture 5 distinct decision criteria for each of the 4 tasks. In the signal detection theory or reduced model, the decision criteria remained fixed across the discriminability conditions, and the target distributions remained fixed across the criterion conditions. In total, there are 14 parameters. 10 decision criteria parameters, and 2 mean and standard deviation parameters for the target distribution. We then used less constrained models, which included the common threshold model, where the decision criteria remained fixed, but the distributions were allowed to vary across the criterion conditions. We used a common distribution model, where the distributions were fixed across criterion conditions, but the criterion could differ across discriminability conditions. And finally, we used a full model where both decision criteria and distributions could vary across each other. We compared the 4 models against each other at the individual level. The lower the AIC or BIC value, the better the model fit. The AIC revealed that about half the participants in our study showed that the reduced model was actually the best fitting model, but other subjects did not show the reduced model or the signal detection theory model as the best model. However, when looking at BIC, which more heavily penalizes more parameters, almost all the subjects showed that the signal detection theory model was the best fitting model, with the exception of a handful of subjects in which the common distribution model turned out to be better. What this tells us is that signal detection theory is in general a good theory to model participants on, but there are individual differences. This is an ROC plot for subject 20 across all 4 conditions using the full model. If you look at the reduced model or the signal detection theory model, this model actually fits the data pretty well, making the signal detection theory assumption that decision criteria and discriminability are independent behaviors seem valid. However, when you look at a different subject, say subject 5, you could see that these points are much different. Under the full model, these lines are kind of all over the place, and in the reduced model, these points just don't line up very well to the ROC curve. So what this tells us is that although signal detection theory oftentimes provides the best fitting model at the individual level, there are these individual differences where some individuals just do not conform to the signal detection theory model. And we believe that these individual differences should be considered when making model comparisons, because these differences may actually represent unique individual abilities or strategies for how an individual integrates memory evidence with a decision criteria.